everyone, welcome to my mathematics class. Today we'll study limits of trigonometric functions. Uh, in limits of trigonometric functions, firstly we'll discuss some standard results. Here, in some standard results, I have taken here limit of sine theta as theta tends to 0 means 0, and limit cos theta as theta tends to 0 is equal to 1. We will see how they are 0 and 1 respectively. Let's prove. Geometrically, we will take the help of a triangle to prove these results. Proofs. Let me take one triangle and a triangle, right angle triangle you can. Theta, this is sorry here 90 degree, and this one is, let's take reference angle theta A B C, and this is a right angle triangle. If this one is reference angle, then this will be a perpendicular, or this will be a perpendicular, and this one is your base, and this one is officially your hypotenuse. Hypotenuse, and we can say this one is a P, small p, and this one is a B, and here H. Yes, okay. Let your A, B, C be a right angled triangle with angle ABC is equal to 90 degree, right? Then let's find out sine theta. Already you know sine theta. Sine theta means perpendicular upon hypotenuse. Perpendicular upon hypotenuse, and we have here AB upon AC, right? Sine theta, here see, sin theta means perpendicular upon hypotenuse. Cos theta is your base upon hypotenuse, because we need here sin theta and cos theta. That's why I'm not going to discuss the other trigonometric ratios. And cos theta is equal to base upon hypotenuse. Base means your BC upon hypotenuse your AC. Okay? Alright. We want to find out the value of the limit of function sin theta, limit of sin theta when theta tends to 0. This is the important thing, okay? Theta tends to 0. See what happens, okay, if theta tends to 0 here. When theta approaches 0, and theta, this is your A, this is your B, and this is your theta. See, okay. Now you can see very carefully, if theta, okay, theta tends to 0 means theta, okay, moves this side, like this way, like this way, like this way, approach it. And then, so, with approaching theta, tends to 0, approaching 0, theta, with approaching theta 0, your AB, and there will be decrease in the length of AB, or you can say the height of AB, so then A will come here, right? A will come here. If okay, theta again, okay, then A will be here, and theta, okay, theta is moving towards 0, 0, okay, when two lines, here is okay angle, certain angle between these two lines will line on the line, then there will be angle 0, right? Line, when the lines coincide with each other, then angle between them you can see 0, okay, in this case also. And now here one, if okay theta, okay, then A here, and finally theta is here A, and theta okay, almost okay, and near to 0 okay, theta here A and near to 0. And what will happen okay, when theta tends to 0, here we experienced okay, AB, there will be no height, there will be no perpendicular there, and it will almost to 0. AB tends to 0, length of AB tends to 0 here when theta tends to 0, and your AC becomes BC, AC becomes okay equal to BC, and AC tends to BC, you can see. Alright, so I think it's clear from this diagram. Now here I'm going to write when theta tends to 0, then when theta tends to 0 okay, then your AB tends to 0, right? See, here is like this, we can say sub when angle okay 0, theta tends to 0 means okay, angle is going to be reduced gradually, like this, like this, like this. Firstly here A, then theta. Now here angle will be angle between okay AB and AC will be almost to 0. Then there will be no perpendicular, right? Then that's why okay AB tends to 0, and your AC or CA you can say tends to BC, and the length of CA will be equal to okay, BC, in which case when theta tends to 0, when theta approaches 0, this angle approaches 0. Okay, now you can say I'm writing here now. Let's find out this for standard result. Limit of sine theta as theta tends to 0 is equal, we can write down the limit theta tends to 0 sine theta. What is the sine theta? AB upon AC. Okay, when theta tends to 0, then AB, you can say again I'm writing okay, when theta tends to 0, AB tends to 0. Okay, when theta tends to 0, then AB tends to 0, and here AB upon AC, and okay, AC tends to BC, so we can write when theta tends to 0, we can say AB tends to 0, and AB means 0 upon AC and BC equal, and so we can say either you can write AC or you may write down the BC also, you may write down also. We can write down the okay BC or BC also, or AC also, okay, it doesn't matter, okay, AC. Alright, from this we will get okay, and it is going to be equal to 0 when theta tends to 0, then limit AB tends to 0, AB, so 0 upon AC, AC is equal to BC also, you can see here. If you want to write down okay BC also, you may write down okay, right, as okay theta tends to 0, AB tends to 0, and your CA tends to BC. Okay, both have the same equal value, so equal to 0. Therefore, we can say limit theta tends to 0, sine theta is equal to 0. Limit of sine theta as theta tends to 0 is equal to 0. Geometrically, we came to know the limit of sine theta is equal to 0 as theta tends to 0, when theta tends to 0. Okay, let's see for the second standard result. For second standard result, now I'm going to erase this here, this side. I've explained all things, and now cos theta, again you need to take a limit of cos theta when theta tends to 0 is equal to limit theta tends to 0 cos theta, okay, BC, your BC upon CA. Cos theta means BC upon C. Again, I'm making diagram here. You can see A, here B, here C, here 90 degree, and this one is theta, right? So you can see, okay, this is a perpendicular, this is a base, this one is a hypotenuse. Cos theta means your base upon hypotenuse. So BC upon AC. And you know, when theta tends to 0, this cos theta's value we have put here. When theta tends to 0, we can write down here or CA tends to BC. Okay, so here BC upon CA, and finally we can write down the BC upon CA also BC is equal to 1. Here, okay, as theta tends to 0, then CA tends to BC. When theta tends to 0, 0, 0, okay, when it goes, when it moves like this way, then finally when theta becomes equal to 0, at the time your AC will be equal to BC. Here you can experience here AC equal to BC and BC. So is equal to 1 geometrically, and finally you can write down, therefore limit theta tends to 0, limit of cos theta when theta tends to 0, or limit of cos theta as theta tends to 0 is equal to 1. Two standard results with the help of geometry we have proved. Okay, I think you were clear about these two results. Now you don't have confusion. Now in your brain you can keep only one thing, limit of sine theta as theta tends to 0, and limit of cos theta as theta tends to 0 is equal to 1. Okay, so now we will see the next very important theorem in limit of trigonometric functions. Okay, now you are going to see very soon. All right. Now I'm going to tell you a very important theorem in limits of trigonometric function. Without this theorem, your limits of trigonometric function is incomplete, almost incomplete, impossible, you can say. Limit of sine theta over theta when theta tends to 0 is equal to 1. If you see this function, this is in indeterminate form. When theta tends to 0, sine theta tends to 0, and theta tends to 0 means 0 upon 0. This is in indeterminate form, right? Now we have to today prove limit of this function when theta tends to 0 is equal to 1. But very important thing here, which is to be noted down, theta is measured in radian. So we don't do in degree, and in degree it is not also possible in radian, okay. And theta is measured in radian, okay. If we have a function in degree, firstly we need to convert into radian, and then we find out the limit of function, okay. So let's see, okay, today how to prove this theorem, very important theorem, and we will use the again geometry to prove this theorem, okay. Here we go. Very simple way I will teach you, I will tell you. Let's make one circle. Let's make, okay, one circle. I think this is not an exact way, but let's suppose this is a circle, and here is a center O, or you can suppose here angle. This is AB, and let's say this is the angle is theta. Theta, okay. I'm writing here, okay, theta. Theta is the angle. Theta, let your theta be the angle right here. Angle in radian. Subtended by an arc AB. Let's suppose, okay, AB at the center of the circle O. At the center O of the circle, okay. Let theta be the, what is the theta here? I suppose theta is the already given also, theta measured in a radian. Theta be the angle in radian subtended by an arc. Subtended by, let's suppose, okay, this angle is subtended by an arc at the center O of the circle. Okay, it's clear. Arc is this one. Now let's suppose, okay, radius, let r and r be the radius, and your radius of the circle. We have supposed this is also, and this also we have supposed, and radius of the circle. And let's draw the tangent at point A. Let's draw the tangent at point A. Tangent. Oh, there is a one property between tangent and radius, because they are at the point of contact perpendicular to each other. That's why here I've made 90-degree angle. 90-degree angle. This is a tangent. I'm writing here. Tangent at tangent to the circle at the point A. This is a tangent to the circle at point A. And let's suppose, okay, which meets OB produced, which means line OB produced at point P. Okay, and I think let me repeat again. Tangent, this is a tangent. Let AP be the tangent. You can write down like this way. So these all you can combine here in description of this figure. Here you can write down, let AP be the tangent to the circle at point A, which meets line OB produced at point P. Okay, we have just produced line OB produced, or OB line extended OB, right? We have extended to point P. Okay, and also join AB. Also join AB. Okay, also join AB. Now you can now see from this diagram we have three triangles. Number one, here I'm not writing this description of the figure. You can describe. I have written here also, this thing also I have explained. All these things you can combine to describe the diagram. Okay, now okay, then we have three triangles. You can see one is a triangle, three triangles, not two triangles and one sector there. You can triangle area of, let's find out area of a triangle OAB. Okay, area of triangle OAB. Now just I'm going to find out the area for this triangle AOB. You know, I think in 10th class you might have studied this formula. If here is theta and here is A and here is a B, then area of triangle is equal to half AB sine theta. This is the formula. In trigonometry in 10th class you might have studied this formula, or you may study in the properties of triangle. Properties of triangle also you may study. Okay, area of triangle is equal to half times the product of two sides times sine theta, sine of angle between the between the given lines, right? If these two lines are given and we take the sine this theta, right? So you can, from this figure is clear, it's obvious, okay, area of triangle is half AB sine theta, you will understand, right? So using this formula, this is a formula we can derive also. If you need, you can tell me. Area of triangle OAB, using this formula we can write from this diagram, area of triangle half times OA times OB, okay, and sine theta is equal to 1 by 2. O is radius, and here is also radius, and here you can sine theta means sine theta is equal to, we can write down 1 by 2 r square sine theta. Okay, this is the area of a triangle OAB. Now I'm going to find the area of a sector OAB. Now I think, okay, you might have a problem. You can, so which one is the sector? Okay, right? So here is OAB. I have written here triangle. So what is the sector? Let me okay here write down. Let me show you this type of diagram. Okay, here part of the diagram only which is a sector I am taking. This one is, and A, B, and this one 0, and so I here theta and R, this is your R, and this one is the arc. Okay, all right, arc. Okay, this diagram OAB, this one, this is called your sector. What is this? Your sector. This is a sector. Area of a sector. What is the area of sector? When you started trigonometry, you studied, okay, length of arc, right? And how to find out the area of sector at that time, or before that you might have a study about that. So for this formula we have half r square theta. If theta is in radian, okay, if theta, if theta is in radian, if theta is not radian, then we use, okay, something 1 upon something, but we don't use this. This formula will be used, okay, if theta is in radian, half times r square theta. This is also formula to find out the area of a sector. Okay, so directly using, okay, formula I am writing, okay, half r is square. Here is radius r, and angle between them is theta. Theta is also in radian. Okay, we can write down the area for sector OAB is equal to half r square theta. Now third, okay, diagram I will take, okay, OAP. Area of your triangle OAP is equal to, listen to me here, OAP is a right angle triangle which is right angle at A. In diagram you can see here 90 degree. If this is 90 degree, this side is also 90 degree, then we can use, okay, half times your base is your AP will work as a base, and your OA, and OA base times height. Oh, sorry, AP, no, according to the reference angle, AP will be your perpendicular, OA will be your base. Okay, all right. Yes, so no problem. Half time the size containing 90 degree we can take. If we have triangle is right angle triangle. Okay, so let's find out the value of AP. AP, okay, 1 by 2. I'm going to write down, okay, this side is equal to 1 by 2 AP. If you see, okay, this triangle AP upon OA, AP upon OA is equal to tan theta, and AP is equal to OA tan theta. Okay, so what is the value of OAP? By using, okay, trigonometrical ratio, okay, AP is your perpendicular, OA is your base, okay, tan theta is equal to perpendicular upon base. Okay, so from here AP we can find out OA sin theta. So let's write down, okay, OA, sorry, sin theta, not tan theta, and times OA. Very important theorem, very important theorem. You have to go through each and every step of this theorem, whether you are studying in any, okay, school, or in any, if you are this, if you did, okay, this theorem, then definitely, okay, this topic is going to be very helpful. Yes. Okay, and useful, and also 1 upon 2 here OA is the radius r, and OA is again r, and here tan theta, so we can say half r square tan theta, half r square tan theta. Okay, now clear. Area of a triangle OAB done, area of sector OAB done, and area of a triangle OAP also done. Okay, and there is no problem. I think everybody understood clearly. Okay, now I need okay, space. I'm going to remove okay, this portion from here to write down the remaining things. Okay, now if we see the diagram, okay, from the diagram we have, okay, from the diagram we have, if you see the area, you know, right, OAP, right, inside of OP we have a triangle sector OAB, and inside the sector we have triangle OAB. So from this diagram we can say area of a triangle, we can say, at least we can say this one, area of a triangle OAB less than area of your area of, you can say, sector OAB, all right, sector OB, and less than uh, area of a triangle OAP. Clear? OAP. Now see once again, okay, area of triangle OAB, and OB is inside the sector OAB. So sector OAB is definitely has greater area than this. Then area of means sector. Okay, this diagram of sector is inside the diagram of a triangle OAP. So definitely, okay, area of a sector OAP is less than the area of triangle OAP. This is your OAP, right? OAP. OAP, and this is a, once again I am writing, okay, OAP. Now listen to me everybody, OAP here. Now listen to me here, less than, when theta tends to 0, right, listen to me, when theta becomes, okay, very near to 0, when theta approaches, okay, 0, at that time, okay, so let me explain here. At the time, just imagine what will happen, okay, this time, okay, theta is this one. When theta is 0, then, okay, your line, okay, will come this another one. When theta approaching, okay, finally, okay, B will be here, okay, A, and this is a B, this is A and B will coincide, okay, almost, okay, they will be in position to coincide, okay, and at that time, okay, you can just think all these figures will be similar to each other, right? All will be tends to be look like a same thing, right? Same figure. Okay, at the time we can say when theta tends to 0, right? When theta tends to 0, and then we may have, okay, area of triangle OAB less than equal to, means area of, we can write on both condition, sector of OAB. So we are combining, this is the general case, if theta is greater than 0, when theta tends to equal to 0, at the time, okay, area of a triangle OAP, right? Or simply without using this condition also we can do, just we can find out, we can simplify this portion. At last we can use quiz principle. uh, okay, so now I'm going to put the values of this one. Area of triangle OAB, half r square sine theta, okay, and less than equal to half r square theta, less than equal to half okay, your r square tan theta. Alright, already we have calculated area for all these diagrams. And if you now, let's simplify here, half r square will be cancelled from each term. We will have here sine theta, and simply theta less than equal to your tan theta. Now let's divide each and every term. Let's divide each and every term by sine theta. It's gonna be sine theta less than equal to theta upon sine theta less than equal to tan theta upon sine theta. Or next step is 1 less than equal to theta upon sine theta less than equal to here. Okay, sine theta upon cos theta divided by sine theta over sine theta. We can write it like this way. One more step, 1 less than equal to theta upon sine theta. I think you can see very easily, and understanding sine theta get cancelled, and we will get 1 upon cos theta. Okay, and now actually we want to prove, okay, this one, a limit when theta tends to 0, sine theta upon theta is equal to 1. We want to get the value of this, means limit, okay, value actually, okay, limit, okay, okay, value of this one you can say, okay, right? I mean, okay, all these things, what will be the value of this one, okay, limiting value. Let's see, okay, because here theta upon sine theta, we need sine theta upon theta. In order to find out the sine theta upon theta, let's reciprocal each and every term here. If we reciprocal, there is a property in ordered properties. I think you might have studied in real numbers. If you have not studied, then okay, if you do the reciprocal, your sign of inequality will be reversed. And here, okay, sine theta upon theta greater than equal to cos theta. Let me explain one with a very simple example. So here, if okay, 10 is less than 20, there is no problem, right? If we do reciprocal, you're gonna get here, okay, 1 upon 10, here 1 upon 20. Let's check, okay. Here in this position you are not able to detect immediately, so here 0.1, and here 0 point, you can, okay, 0.0, 20, here 10, 100, 0.05, I think you getting here, right? And 20 times 0.05 is equal to 25 is 100, and 2 zeros, okay, and okay, 25 is um, 0.1 here. So let me, okay, 25 is 100, and 1 2, okay, 1 2, here 1, okay, all right. So it's correct to be 0.1 is greater or 0.05. So officially 0.1 is greater than 0.05, okay, all right. So see, okay, we have firstly, okay, 10 is less than 20. Now if we do reciprocal, and sign of inequality will be reversed, right? Okay. So using this, and here I have explained, okay, this is the property you might have studied in ordered property of real numbers. Okay, now we need, okay, limit of this, taking limit, taking limit as theta tends to 0, we get here limit theta tends to 0 1 greater than or equal to limit theta tends to 0 sin theta upon theta greater than or equal to limit theta tends to 0 cos theta. Okay, we don't need to, okay, diagram. Now without diagram also we can here. Okay, here see, after this I'm writing here limit of 1 is 1, limit of constant as theta tends to 0 being 1 constant greater than or equal to, so limit, let me write down, otherwise I'll not get space here, here or 1 greater than or equal to, limit of 1 is 1 as theta tends to 0. Same thing, we'll write down this one because we want to get the value of this whole thing, mean to limiting value sin theta of theta greater than or equal to, already we have proved, okay, limit of cos theta when theta tends to 0 means 1. Okay, so here you can see 1 greater than this, greater than 1, or greater than or equal to this, or greater than equal to this, and you can say therefore this is equal to limit as theta tends to 0 of sin theta upon theta is equal to 1. Or you can say by using squeezing principle or squeeze principle, or simply from this is a self-evident, 1 greater than or equal to 1 equal to this or equal to 1. This means, okay, limit sin theta upon theta as theta tends to 0 is equal to 1. when theta is measured in radian. So one of the very important theorem in limit of trigonometric function. I think you understood how to prove. Okay, everybody. So if you have any problem, you can write down comment and to me and ask the problems. If you get any, I will try to answer each and everybody's comment about this question, this theorem, and I hope okay. I'm supremely confident you all understood okay, and how to prove this theorem. And now I think we will not forget it. Limit of sine theta over theta as theta tends to 0 is equal to 1. Okay, thank you for watching. Or till next video, just wait and watch and stay with my channel if you are a regular student and if you are regularly watching. If you are newcomer, and so get connected and just subscribe and press bell icon, you will be get connected. Okay, so thank you once again. Bye bye.